Hey, what's up guys? Welcome to CertBros. In this video, we're going to be looking at IP addresses. More specifically, IP version 6 addresses. So, we've already looked at IP version 4 addresses in the previous videos. But there's a problem. When IP version 4 first came out, the people that designed it sat back in their chairs and said, "We've done it. We've created every IP address that anyone will ever need." How many addresses did they create? 4,294,967,296 addresses. Which sounds like a lot, right? But at the time, they couldn't have imagined the massive explosion of devices that would require an IP address. If you think about every device you own, like a PC, laptop, smartphone, TV, etc., it quickly became apparent that we would soon run out of IP version 4 addresses. The solution is to eventually move over to the new IP version 6. IP version 6 provides us with, well, I'm not even going to try and say that number, but it's a lot. Aside from the number of addresses, IP version 6 also brings a lot of other improvements that makes it a lot more efficient and practical. Okay, so let's dive into what an IP version 6 address looks like. Let's first remind ourselves of IP version 4. It's 32 bits in length. Remember, bits refer to the binary digits of the address. It contains 4 sections called octets, which are separated by dots. And, in theory, each octet can contain any number between 0 and 255. Now we're familiar with our good old friend IP version 4, let's bring in an IP version 6 address. Now, at first, this address looks pretty scary. But don't worry, we're going to break it down step by step. First, let's do some comparisons. We know our IP version 4 address is 32 bits long, but our IP version 6 address is 128 bits long. This is where we get our massive IP address space from. IP version 4 has 4 sections called octets. IP version 6 has 8 sections, but these are commonly called hextets. IP version 4 uses dots to separate octets, but IP version 6 uses colons to separate hextets. So let's get rid of our IPv4 address and go into some more detail. The first thing you probably noticed is there are letters in this IP address. IP version 6 is hexadecimal, meaning each character can be between 0 and 9, or A and F. Let's take a look at how IP version 6 works when it comes to binary. This is especially important when it comes to subnetting. Each hexadecimal character is made up of 4 binary bits. These bits can either be a 0 or a 1. Each bit represents a value of 1, 2, 4, or 8. It doubles with each column from right to left. Wherever we see a 1, that toggles that column on, and wherever we see a 0, that toggles the column off. We then add up all of the columns that have a 1, and this gives us our number, or letter. So let's take the first number from the address, which is 2. How do you think we can make the number 2 from our binary bits? We simply add a 1 in the 2 column. All other columns stay as 0 because we don't need them. So the binary value for our first number is 0010. We're going to go through a few of these just to make sure it sticks. The second number in our address is 0. How do we get 0? Well, we simply leave all the columns off. So this gives us a binary value of 0000. Our next number is also 0, so it's the same. Now we have number 1. Just like with before, we turn on the column for 1 and we leave the rest as 0. Our binary value is 0001. We have yet another 0, so we know our binary value will be, well, all zeros. This next one we do need to look at. How do you think we get the letter D from our binary chart? Well, if you remember, I mentioned that each character can either be 0 to 9 or A to F. Clearly, we can make bigger numbers with our binary chart than 9. In fact, we can get up to the number 15 if we turn on all the columns with a 1. The problem is, we can't use double digits. So instead, we swap out 10, 11, 12, 13, 14, and 15 for A, B, C, D, E, and F. So now we know that, how do we get the letter D? D has replaced the value 13, so this is the number we need to get. You should always start with the highest number you can, and in this case, that number is 8. Then the second highest, which is 4, this gives us 12, so we only need one more. We'll leave the 2 column off because this would make our number too high, and turn on the 1 column. Add this all up and we get 13. So that means our binary value for D is 1101. Hopefully you get the idea by now. If you were to continue doing this, you would eventually end up with the full binary value. Okay, so that's our brief binary lesson. It's not something you'll do every day, but it is important to understand, especially when looking at some more in-depth subnetting. Okay, so just like IP version 4, IP version 6 has a network section and a host section. The way IPv4 does this is by using a subnet mask. However, IP version 6 has gotten rid of the subnet mask, and instead it just uses a / and the number of network bits, which you should be familiar with from IP version 4. So, in our example, /64 is half of our 128-bit address. /64 addresses are common when it comes to IP version 6. It splits it nicely down the middle and ensures we have plenty of networks and plenty of hosts. But be prepared to see different numbers. Remember, each character is 4 bits long and each hextet is 16 bits. We'll now look at how we compress this address to make it look a little nicer. I'm sure we can all agree that this is a lengthy address, and the thought of typing this out over and over again is simply horrific. But there are a couple of tricks that we can do to make this address a bit more bearable. The first trick is to remove continuous zeros. Because we find ourselves with so many addresses, a lot of the time we see multiple hextets next to each other that contain only zeros. We can simply replace all of these zeros with a double colon. When the computer sees this address, it sees the double colon, works out there are 2 missing hextets, and then fills in the zeros. The rule to this trick is it can only appear once. For example, if we change this address slightly and add another hextet of zeros, we cannot add another double colon. If a computer looked at this address, it has no way of filling in the missing pieces. How would it know if the address is missing 8 zeros from here and 4 zeros from there, or 4 zeros from here and 8 zeros from there? So this is why it can only happen once. But there is another trick we can use. We take all of the leading zeros from each hextet, so where it starts with 1 or more zeros. We have 1 here and 3 there. Then we simply remove them. So now, when the computer looks at DB8, it realizes there is a missing character and it fills in the gap. The same thing happens on this hextet. Note that even though it's all zeros, because we already used the double colon, we need to leave the last 0. And this is the address we're left with. Still pretty large, but it's a big improvement from where we started. Okay, so moving on. Just like IP version 4, there are different types of IP version 6 addresses, and they serve different purposes. What we see here is called a global unicast address. You can think of this like a public IP version 4 address that is routable over the internet. Unlike IP version 4, because we have such a massive amount of IP addresses, we no longer need to rely on private addresses. Every device can have its own public IP address. The first part of this address is known as a global prefix. This is what your ISP will provide you as a block of IP addresses. This global prefix will be a minimum of 48 bits long. Once we have the global prefix, We can then use the next 16 bits for our subnet ID. 16 bits gives us over 65,000 subnets to play with. And that leaves us nicely with a 64-bit host or interface ID. Okay, so let's look at some other address types. We have global unicast, which we just looked at. This is a publicly routable address like the IPv4 public IPs. The prefix to identify these addresses is 2000:3. This means the first 3 bits identify a global unicast address. It will start with either a 2 or a 3. Next, we have a unique local address. This address is like an IPv4 private address. These are not globally routable. The prefix to identify a unique local address is FC00:7. Using the first 7 bits, a unique local address will always start with an F followed by either a C or a D. Link local addresses. Think of these as quick, automatic private IP addresses that are not routable over a network. They are designed to communicate only within a single area of a network. You may have seen the dreaded 169.254.something.something address when your computer can't connect. This is pretty much the IPv6 replacement. You can identify a link local address because it has a prefix of FE80::/10. This means the link local address will always start with FE. Multicast addresses. These are addresses that are sent to a group of computers or devices listening for that particular multicast address. IPv4 used to also use broadcast addresses. These were sent to all computers within a network. These have now been scrapped with IPv6. Multicast addresses are easy to spot because they always start with FF. Okay, last but not least, we have something called an Anycast address. Now these are interesting because IPv6 allows us to assign the same IP address to multiple devices. The data is then sent to the closest device with that address. There isn't a specific IP range for Anycast addresses. They use the same range as global unicast. So as you can see, the prefix is the same. Now it's really important to be able to look at an IPv6 address and identify the type. So to recap, global unicast addresses will start with either a 2 or a 3. Unique local will start with an F followed by C or D. Link local will always start with FE. And multicast will always start with FF. Okay, so I think that's enough for one video. You should now understand the fundamentals of IPv6. This video is part of our full CCNA course, which can be found in the description, so please feel free to go and check that out. If you liked this video, don't forget to give it a thumbs up, leave a comment and subscribe. The support from you guys really does help this channel grow. Other than that, I hope this video helped and thank you for watching.